Lesson 6, Linear Systems and Solving Problems. So we have two numbers whose sum is 25 and whose difference is 11. So let's let x equal the first number and y equal the second number. We don't have to worry about using meaningful variables for this because it's just two numbers, so they can be x and y. So when you add them together, their sum is 25. And when you subtract them, their difference is 11. Because we have this variable and this variable will cancel each other out, we can use elimination very quickly. So x plus y is equal to 25, x minus y is equal to 11. To find our answer, we want to add the two equations together. So 2x plus 0y is equal to 36. So 2x is equal to 36. Divide both sides by 2, and x is equal to 18. Substitute 18 in for x, and you get 18 plus y is equal to 25. Subtract 18 from both sides, and y is equal to 7. So the two numbers are 7 and 18. And of course you could check that. 18 plus 7 is 25, and 18 minus 7 is 11. Make sure you write a sentence to show that you understand what it is you solved for. Jessica and Lori were comparing the number of hours each of them had worked during the past week. So let's do our let statements. We have Jessica and Lori, so let's let J equal Jessica's hours and L equal Lori's hours. They noticed that between the two of them, they had worked 66 hours. So when you add them together, it's 66. And Lori worked 6 more hours than Jessica. So Jessica plus 6 more is equal to Lori. Now we have an easy way to substitute because we have one variable isolated. So we're going to substitute j plus 6 in for L. So j plus 6 is equal to 66. J plus j is 2j plus 6 is 66. Minus 6 from both sides, and 2j is equal to 60. Divide both sides by 2, and j is equal to 30. And j plus 6 is equal to L, so 30 plus 6 is equal to Lori, so 36 hours is what Lori worked. So Jessica worked 30 hours, and Lori worked 36. Example 3. Commissioner removed 76 coins consisting of loonies and quarters from a parking meter. So there's 76 coins, and the value of the coins was $37.75. How many of each coin were removed? So let's let L equal loonie and Q equal quarter. So when we add them together, the loonies plus the quarters, there's 76 coins. We know that the total number, or total value of the coins is $37.75. Loonies are $1 and quarters are $0.25. So if we add 1 times L plus 0.25 Q, we get $37.75. We have an L and an L, so it's easy to use elimination. So L plus Q equals 76, and L plus 0.25 Q equals 37.75. We want to subtract to get rid of our L's, so L minus L is 0L. Q minus 0.25 Q is 0.75 Q. And 76 minus 37.75 is 38.25. So 0.75 Q is 38.25. Divide by 0.75, and Q is equal to 51. Now we're going to substitute 51 in for Q. So L plus 51 is equal to 76. Minus 51 from both sides, and L is equal to 25. So there are 51 quarters and 25 loonies in the parking meter. An art gallery has a collection of 85 Northwest Coast masks of people and animals. 60% of the people masks and 40% of the animal masks are yellow, and there are a total of 38 yellow masks altogether. So let's let P equal people masks and A equal animal. When you add the people plus the animal, you get 85 masks. 0.6 of the people and 0.4 of the animal is equal to 38 masks. So it's very easy to isolate a variable, so I'm going to subtract A from both sides, so P is equal to 85 minus A. So we can substitute 85 minus A in for P. So 0.6 times 85 minus A plus 0.4A is equal to 38. Distribute in, and 0.6 times 85 is equal to 51 minus 0.6A plus 0.4A equals 38. Negative 0.6 plus 0.4 is the same as negative 0.2A. Subtract 51 from both sides, and negative 0.2A is equal to negative 13. Divide both sides by negative 0.2, and A is equal to 65. So we're going to substitute 65 back to our original equation. So P plus A is equal to 85. P plus 65 is equal to 85. Minus 65 from both sides, and P is equal to 21. So there are 65 animal masks. Aminal, I can't believe I just did that. Animal, I almost did it again. And 21 people masks in the art gallery.